Hexavalent chromium is a toxic form of the element chromium. The hexavalent chromium compounds are man-made and are widely used in many different industries. Some of the major industrial sources include chromate pigments in dyes, paints, inks, and plastics, chrome plating, smelting of ferrochromium ore, fume from welding stainless steel or non-ferrous chromium alloys, impurity present in Portland cement. The primary means of human exposure are inhalation, ingestion, and skin contact. It can be inhaled when hexavalent chromium dust, mists, or fumes are in the air. Particles of chromium dust can contaminate hands, clothing, food, beverages, and facial hair. The National Institute for Health, or NIOSH, considers all hexavalent chromium to be potential occupational carcinogens. For those of you who remember the movie Erin Brockovich, hexavalent chromium was the contamination found in the small town in California and brought so much attention to it.
Well, as in the Oscar-winning film Erin Brockovich, this is a substance that really has carcinogenic properties and can get into very, very commonplace sources of ingestion, such as water sources. And so it's the kind of thing where if it's not controlled properly, it can be very dangerous to all the population. This is really beyond the workplace, but the source is in the workplace.
Workplace exposure to HC may cause the following health effects: lung cancer in workers who breathe airborne HC, irritation or damage to the nose, throat, and lung if HC is breathed at high levels, irritation or damage to the eyes and skin if HC contacts these organs in high concentrations. Repeated or prolonged exposure can cause sores to develop in the nose and result in nosebleeds. If the damage is severe, the nasal septum, or the wall separating the nasal passages, develops a hole in it. Some employees become allergic to HC, so that inhaling chromate compounds can cause asthma symptoms such as wheezing and shortness of breath. Naturally, there are skin reactions and potential of cancer when exposed to hexavalent chromium. The new OSHA workplace standard requires employers to limit 8-hour time-weighted average HC exposure in the workplace to 5 micrograms or less per cubic meter of air. Perform periodic monitoring at least every 6 months if initial monitoring shows employee exposure at or above the 2.5 micrograms per cubic meter of air, which is calculated on an 8-hour time-weighted average. We call the 2.5 micrograms an action level, which means certain action must be taken to reduce the exposure. Appropriate PPE, or personal protective equipment, would be necessary when there is likely to be a hazard present from skin or eye contact. Certainly, respirators would be a requirement in most cases. Implement good personal hygiene and housekeeping practices to prevent HC exposure. Prohibit employee rotation as a method to achieve compliance with the exposure limit or PEL. Make available medical exams to employees within 30 days of initial assignment, annually to those exposed in an emergency situation, and to those who experience signs or symptoms of adverse health effects associated with HC exposure. Medical exams are also to be provided to those who are or may be exposed at or above the action level for 30 or more days a year and at termination of employment.
Basically, when OSHA and the Department of Labor and the representatives of labor proposed the standard, it was going to be 1 microgram of hexavalent chromium for every cubic meter of air. But when the standard was finally published, the standard was 5 times that amount. That posed 2 very important problems. First of all, procedurally, agencies have an obligation to be consistent with what they say they're going to do. That's true of just about every agency in America, regardless of what it is they're supposed to be doing. So there was a real procedural problem, and people were taken by surprise. And of course, the related matter is it was not clear from a scientific standpoint why that changed. And it was not clear whether science could really support that kind of a difference in the standard at the end of the process compared to its proposal.
Chromium is a naturally occurring element found in animals, rocks, plants, soil, and in volcanic dust and gases. Chromium is present in the environment in several different forms. The most common forms of chromium are chromium 0, chromium-3, and chromium-6. Chromium-3 occurs naturally in the environment, whereas chromium-6, or hexavalent chromium, is produced by industrial processes. People can be exposed to chromium by eating food containing chromium-3, breathing contaminated workplace air, or skin contact during use in the workplace, drinking contaminated well water. Exposure can occur for those living near uncontrolled hazardous waste sites containing chromium or industries that use chromium. Chromium-6, or hexavalent chromium, is classified as a carcinogen, lung cancer in particular. The World Health Organization, the Department of Health and Human Services, and the EPA all have classified HC as a human carcinogen. This underscores the necessity to follow the rules, wear appropriate PPE when required, and obtain proper airborne monitoring and medical exams as required. HC exposure can be controlled when you take the proper precautions and follow the rules. It's important for your health to do exactly that. Exposure determination. Each employer covered by this standard must determine the 8-hour TWA exposure for each employee exposed to hexavalent chromium. OSHA allows employers to choose between a scheduled monitoring option and a performance-based option for making exposure determinations when there is the potential for exposure to HC at or above the action level. The action level is set at 1/2 of the PEL, or 2.5 micrograms per cubic meter of air calculated as an 8-hour TWA. Because employee exposures to airborne concentrations of HC are variable, workers may sometimes be exposed above the PEL, even if exposure samples, which are not conducted on a daily basis, generally are below the PEL. Maintaining exposures below the action level provides increased assurance that employees will not be exposed to hexavalent chromium at levels above the PEL because of exposure variations in the workplace. Regulated areas. The employer must establish a regulated area wherever an employee's exposure to airborne concentrations of hexavalent chromium, or can reasonably be expected to be, is in excess of the PEL. The employer must ensure that regulated areas are demarcated from the rest of the workplace in a manner that adequately establishes and alerts employees of the boundaries of the regulated area. Methods of compliance. Employers must use engineering and work practice controls to achieve the proposed PEL, or the lowest levels feasibly achievable. This could include ventilation systems, materials substitutions, or work practice modifications. Wherever feasible engineering and work practice controls are not sufficient to reduce employee exposure to or below the PEL, the employer must provide respiratory protection. Rotating employees to different jobs to achieve compliance with the PEL is prohibited. Respiratory protection. The employer must provide respiratory protection for employees during periods necessary to install or implement feasible engineering and work practice controls. Work operations such as maintenance and repair activities for which engineering and work practice controls are not feasible. Work operations where controls are not sufficient to reduce exposures to or below the PEL. Work operations where employees are exposed above the PEL for fewer than 30 days per year and the employer has elected not to implement engineering and work practice controls to achieve the PEL. Emergencies. Protective work clothing and equipment. Where a hazard is present or is likely to be present from skin or eye contact with HC, the employer must provide appropriate personal protective clothing and equipment at no cost to employees, and it must ensure that employees use such clothing and equipment. In addition, a stringent program must be developed for removing, handling, and cleaning contaminated clothing and equipment. Housekeeping and hygiene. All surfaces must be maintained free of accumulations of HC, and all spills and releases of HC-containing material must be cleaned up promptly. Dry shoveling, sweeping, and brushing may be used only when HEPA filtering, vacuuming, or other methods that minimize the likelihood of exposure to HC have been tried and found ineffective. Effective wet shoveling, sweeping, and brushing are allowed. OSHA also allows the use of compressed air to remove HC when no alternative method is feasible, but only when used with a ventilation system designed to capture the dust cloud created by the compressed air. Waste, scrap, debris, and any other materials contaminated with hexavalent chromium and consigned for disposal must be collected and disposed of in labeled, sealed, impermeable bags or containers. Employers must provide washing facilities in areas where skin contact with HC can occur and ensure that employees use them as needed. Medical surveillance. Medical surveillance is required for employees experiencing signs or symptoms of the adverse health effects associated with HC exposure or those exposed in an emergency. Emergency means any unexpected and significant release of HC, such as equipment failure, rupture of containers, and failure to control equipment. Employers must make medical surveillance available at no cost to the employee and at a reasonable time and place for all employees who are occupationally exposed to hexavalent chromium at or above the action level for 30 or more days a year, experiencing signs or symptoms of the adverse health effects associated with HC exposure, exposed in an emergency. Hazard training and communication. The signs, labels, and training used for a hazard communication program also apply to this standard. The only additional training required is related specifically to the contents of this HC standard. Employers must ensure that each employee can demonstrate knowledge of the contents of this standard and the purpose and a description of the medical surveillance program required by this standard. In addition, employers must provide a copy of this standard to all affected employees. Record keeping. In keeping with its intent to be consistent with the hazard communication standard, OSHA has provisions for exposure records to be maintained, including all data related to air monitoring, date of measurement, the operation involving exposure to hexavalent chromium being monitored, sampling and analytical methods used and evidence of their accuracy, and the number, duration, and the results of samples taken. The type of personal protective equipment worn, such as respirators. The name, social security number, and job classification of all employees represented by the monitoring, indicating which employees actually were monitored. An accurate record of all objective data relied upon to comply with the requirements of the standard, including the chromium-containing material in question, the source of the objective data, the testing protocol and results of testing or analysis of the material for the release of HC, a description of the process, operation, or activity, and how the data support the determination, and other data relevant to the process, operation, activity, material, or employee exposures. An accurate record for each employee covered by medical surveillance under this standard, including the physician's written opinions. You can see there are numerous parts of the standard that require action for compliance. The most important thing to remember about HC compliance is the health and safety of people working in industries who may have this potential exposure.